I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about local beam search algorithm which is used in artificial intelligence. All you know that local search algorithms efficiently solve complex problems by focusing on the best possible solutions instead of exploring the entire search space. These algorithms are widely used in artificial intelligence, optimization, and decision making to find near optimal solutions quickly. They help in handling constraints, improving efficiency, and adapting to real world challenges. Get ready to learn how local search techniques like guild clipping, simulated annealing, and local beam search can revolutionize problem solving. Let us see one by one. First, we'll see the introduction about local beam search. The local beam search is a heuristic search algorithm used in artificial intelligence for efficiently exploring large search spaces. Unlike traditional exhaustive search methods the breadth first search, best first search, or this local search, it focuses on only on a fixed number of k of the best states at each level rather than expanding all possible nodes. This make it a computationally efficient approach, particularly for problem solving where the search space is vast and complex. Next, we'll see the working of local beam search. The algorithm begins by selecting the k random initial states from the search space. These states serve as starting points for exploration. In each step, all k states generate their successors. Instead of considering all successors, the algorithm retains only the best k successor based on a heuristic evaluation function. This ensures that the search remains focused on the most promising paths. The process continues iteratively, replacing the current states with the best successor until a goal state is found or no better successors exist. And these are all the key features of local beam search. One of the primary strengths of local beam search is its efficiency in directing the search toward the optimal solutions. Unlike the blind search methods, it leverages a heuristic function to guide exploration, preventing unnecessary expansion of unproductive branches. Additionally, by maintaining multiple paths simultaneously, the algorithm explores different areas of search space in parallel, improving the chances of finding an optimal solution faster than traditional methods. And the advantages of local beam searches are local beam search offers several benefits. It reduces the computational time by focusing only on the most promising states. No, hence it quickly focuses on the promising solutions. So fast conversions will take place, and the scalability, it works well for large state space compared to the exhaustive search methods. And the main advantage is the less memory usage. It stores only k states at a time instead of maintaining the entire tree. Even though it has got advantages, it has also got some disadvantages, also limitations, that we are calling it as the limitation. Despite its advantages, local beam search has some limitations also. One major drawback is the risk of getting stuck in local optima, where all the selected states converge to suboptimal solution instead of the global best. Another issue is the lack of diversity. If all case states are too similar, the search may not explore enough of the space to find optimal solution. Additionally, selecting an appropriate k value is crucial. A small to missing good solutions, while a large K increases computational overhead. These are all the limitations of local beam search. Now we'll see one example problem. Here, this problem I have taken it for an example. And as far as this problem is considered, here this S is the root node. See here, this S is the root node. Root node is S, and the goal node, this is the goal node. We have to achieve this goal node from starting node to L. And The heuristic value is we are considering lower as the better, and here the beam width we are considering k is equal to 2. We keep only two best possible steps we are taking. Beam step is 2, and this is the first step. So as I've said, this S is the root node, and the goal node is L. Heuristic value, as I've said, lower is the better. Beam with this k is equal to 2. So start at the root node. We begin the search at the root node S, which has two child nodes. What are all the two child? It has got a two child A, and the heuristic value of A is 7, and the heuristic value of B is 10. So the children of S is A of 7 and B of 10. Here it is B of 10 mentioned. And since we are using, what is the k value? K value is equal to 2. We keep the two best nodes based on the heuristic values. The nodes A of 7, this nodes A of 7 and B of 10 are added to the frontier list, meaning that they will be expanded in the next step. At this point, S has been explored, so we add it to the explore list. So now in the frontier list, what are all the values will be there? A of 7 and B of 10. A of 7 and B of 10. And the explore list is yes. And in the next step, we are going to expand A of 7 and B of 10. Expand the nodes A and B. These nodes will be expanded. Next, we expand E of 7 and B of 10 to generate the child nodes. E of 7 expands to, what are they? C of 5 and D8. And this will be expanded to E6 and F9. These two values are expanded. We select two nodes with the lowest heuristic value. So four values are expanded. What are all the two values? This one, C5 and E6 will be taking into the consideration because it has got a lower heuristic value. The best two nodes are C of 5 and E of 6. So we update the frontier list with these two nodes and move A and B to the, where we are moving, to the explored list. So we are going to expand it. So in the next step, if you are expanding C5, the C5, if you are expanding, what you are going to get? G6 and G6 and H of 4. And if you are expanding this, I of 7 and J of 5. This I have given it in the next list. C5, we are going to expand these two, and C5 and E6, because in the previous step, these two have got a less value. So if you are expanding, you are getting G of 6, this one, and H of 4. H of 4 we are getting. And if you are expanding E of 6, you are getting I of 7 and J of 5. These two values are we are getting. So we have to keep H of 4, these two values. Why we are going to keep these two values? These two only got the less heuristic value. So we are going to keep this H of 4 and J5. We are going to keep these two values to generate their child nodes because it has got the less heuristic value. So if you are expanding H4, we are getting K2 and L of 0. Here we are reaching the goal, and here if you are expanding this M3 and N1, N of 1 we are getting. So L as the goal node. Now the explorer list are, so best solutions we are getting it. H of 4, if we are expanding these two, we are next step, these two we are expanding H of L0 and here M3 and L1. So goal node, now the goal node we have reached. So now what is the path found? S to A here, then A to C, then C to H, H to L. This is the path value. L of 0, we found it. S to A to C to H, and L of 0, we found out. So this path is found efficiently using local beam search, as it consistently selects the best two nodes based on heuristic values and avoid unnecessary expansions. So if you want to explain it in table, we can able to explain it for this diagram. So the first start node A and B. A and B we have taken, and then the explore list is yes. If you are expanding AB, the smallest value we have taken EH. So the explore yes, AB will be in the explore list, that is visitor node. C of I and E of 6 we are going to expand it best K nodes. Then the third step, H4, as I explained, H4 and J5. And in the frontier, the explore list, S, A, B, C will be put it into the explore list. That is, these are all the visitor nodes. And finally, we are moving into H expanding, H2 and L0. And J expanding, you are getting M3 and N1. This is what we have given. So finally, we have reached the goal node in the last step. Fifth step, we are getting the reaching the goal node. The goal node value is what? S2A, S2, A2, C2, H2, L. L of 0. L of 0 is the goal node. So what are all the key takeaways from the local beam search? The local beam search focuses only on the best K paths at each step instead of expanding all possible nodes. This selective approach ensures that the algorithm prioritizes the most promising solutions based on heuristic evaluation. By maintaining only the top K candidates, it reduces computational overhead and directs the search efficiency toward the optimal, near optimal solutions. The another advantage is it avoids they are getting stuck in local minima. That is such is that it avoids getting stuck in local optima, not a local minima, local optima, by keeping multiple paths active during searches process. Unlike greedy approaches that may settle for suboptimal solution in the greedy algorithms and all, this method explores different promising directions, increasing the chances of finding the global best solution. This makes it more reliable for solving problems with the complex landscape. Next advantage is, additionally, the local beam search is more efficient compared to brute force search methods. Since it limits the number of expanded nodes at each step, the algorithm requires significantly less time and memory than exhaustive search techniques. By focusing only on most relevant path, it speeds up convergence, making it an excellent choice for optimization problem in artificial intelligence and real world applications. Hope everyone understood this lecture about local beam search and also example problem. The remaining things we'll discuss in the next lecture. Thank you.